Good evening, everyone. It is my pleasure at this time to introduce Dr. Mahesh Das. Uh, Dr. Das is a designer, author, speaker, and technologist exploring urbanism, robotics, and artificial intelligence. He serves as the eighth president of the Boston Architectural College. Dr. Das's work has been featured in scholarly journals, conference proceedings, federal publications, and academic books. Most recently, his co-edited 2018 book, Towards a Robotic Architecture, is the first comprehensive book on robotics in architecture and features 42 researchers from around the world, including the work of our keynote speaker at BAC Talks, Dr. Neri Oxman. The book has been hailed as a best technology book of the year by New York's Architects newspaper. Dr. Das is also the author of Leading with Aesthetics, the transformational leadership of President Charles M. Vest at MIT. Dr. Das is also an award-winning poet and fiction writer in 2 languages in the rich tradition of existentialist and magic realist literature. His forthcoming co-authored book is a graphic novel exploring what it means to be a human and to be a robot. In 2011, he was elevated as an Association of Collegiate Schools of Architecture Distinguished Professor, the highest national recognition for an architectural educator. He was the first person of Indian origin to receive the honor. Dr. Das earned a bachelor's degree in architecture from Jawaharlal Nehru Technological University, Hyderabad, India, a master's degree from Kansas State University, and a doctorate from the University of Pennsylvania. Dr. Das was recognized for his long-standing contributions to design computing with the 2013 Acadia Society Award of Excellence. The Association for Computer-Aided Design in Architecture has elected him twice as its president. He currently serves on the editorial board of Construction Robotics Journal and previously served on the editorial board of the International Journal of Architectural Computing. It is my pleasure to welcome him to the stage for the presentation today.
Thank you so much, Shannon, and very good evening to you all. I hope you're all enjoying BAC Talks, as I have been. What an extraordinary panel discussion that was, that just took place. So, Anthony, congratulations for putting together such a wonderful panel discussion, and thanks to all the panelists and all the participants so far and the attendees. It's so exciting to have this kind of an extraordinary intensity about a topic that matters a lot to us. And as I spoke this morning, you know, technology is probably one of the most important topics that architects and designers of all kinds need to be sure to be at the table, right? So given what is at stake and given what is possible, given what is what we can imagine, and given what we should really avoid as well. So for all those reasons, we have to be doing that. So what I'd like to do today is to really, I call it fresh air as in AI and robotics in architecture and design. So I will focus a bit more on robotics because I think that is a trickier topic a little bit. And so that's what I chose to do today. And so we're going to try to wrap our mind around what does it mean to be a robot? What is a robot? And what's happening in the world today? And what does it mean to design? So that's the arc that I'd like to take us through. So with that, I would like to share my screen and get the presentation going. All right, here we go. So as Shannon has mentioned, the talk is broadly based on the book that came out in 2018 that I have co-edited with my co-author and editor, Andrew Witt. And a number of authors have contributed to this, 42 in all. So a pretty comprehensive book, and still 3 years later, it continues to be the only comprehensive book on robotics in architecture. So as we have been hearing all day long, we are at the dawn of a new era for many reasons, not just because it is robotics, not just because what has been described as fourth industrial revolution or fifth, depending on who you ask, and not just because it is a post-pandemic world that we are entering into, but because of all those together. And so robotics comes at that particular age and stage in the human evolution and in the historical timeline as well. So first, for clarity, I'd like to talk about what is a robot. Bear with me here. So first, a robot is an agent. Robotics is about agency, meaning the ability to do something. And there are three conditions that a robot must meet. One, that it is physical. And second, it embodies certain intelligence. And third is it is autonomous, that is able to carry out certain goals, set the goals for itself, and carry them out autonomously. Although there are three categories within that: autonomous, semi-autonomous, or teleoperated. But nevertheless, let's say autonomy. And there are three things that each robot must do. Number one is it should sense, then think and act, and that cycle must just keep going on, that feedback loop. So sensing, thinking, and acting. So those are the conditions, and that is at least the definition that I have given it, and many in the field have given it. Now let's look into what Isaac Asimov has written about robots. And mind you, these three laws of robots probably have been thrown out of the window a long time ago, that a robot may not injure a human being. We have robotic weapons today, not dedicated to the very task of injuring human beings, or they must obey the orders given by human beings. Maybe not. And third is that a robot must protect its own existence, as long as such protection does not conflict with the first or second law. So those are the kinds of laws that Asimov began with, back when, and now let's see where things are headed. So first, I'd like to offer the first framework of the day: robots by form. The form is very important in robotics: biomorphic, mechanomorphic, polymorphic, or amorphic. So biomorphic means a robot looks like and has a form of an animal or a living being of some kind. It could be a human being, it could be an animal, it could be a tree, plant, flower, whatever, bee, insects. And then the mechanomorphic means that it looks like a machine. A good example is a Roomba. If you have one at your home, you got a mechanomorphic robot. And third is polymorphic. They are transformers, right? So they can transform from one to another. And the last one is amorphic, where there is no particular form, like HAL 9000. It's a robot shape, but you never know what the form of that robot is. So robots in the context of domesticity. Let's look at what is happening. Obviously, Roomba or Brava Jet in this case, or we have HVAC bots like Nest thermostat. If you put one in your home, it turns essentially the HVAC mechanism into a robotic mechanism. Sanitization robots, surgical robots, right? So there are lots of things happening, and same thing in mobility. If you look at the autonomous vehicles, humans try to figure out what is happening between the autonomous vehicles. And that brings up the question of interaction. So it's very important to understand that there are different kinds of interactions that we take into account: robots to humans, robots to architecture, robots to robots, and robots to humans and the environment that they are in. So there's always this kind of a multiple interactive framework that is going on that's important to consider in whatever we think about robotics. Then let's look at how human relationships are being mediated by or impacted by robotics. So we now have companion robots, in this case, a robot in an elderly care setting that provides certain services, and if nothing else, provides companionship. And we know already that Alexa provides certain companionship, and here we have another, if you will, humanoid robot, a biomorphic robot, being able to provide companionship to children, either with special needs or autism spectrum or a variety of other situations, or just simply to play. Then logistics. If you look at logistics, there are a variety of robots coming up that are like cargo robots, personal cargo robots in this case. You could have this, you could own it, you could summon it to wherever you would like. It could wait for you, and it is essentially autonomous and can carry stuff for you. And so that is a category. Or there is delivery robot that FedEx has been trying for a while, and it is possible that future deliveries could be carried out through delivery robots. And another kind of delivery robots, in this case, and you'll see this kind of a duality in each category, where either humanoid form or a mechanomorphic form. Which one is better for which? And here is a little film that makes the case. So you get the idea there. That's a concept video, but nevertheless, we get the idea that it's actually feasible. That's beyond feasibility and now being tested out for different kinds of mobility needs being met through a variety of solutions. This is Amazon's Zoox that is thought to provide, mass transportation solutions still being experimented. Or Waymo that we all familiar with, the trucking systems that are already being tried out, implemented in a variety of cities, or autonomous vehicles of various kind. So, and of course, warehouses, as we talk about more delivery robots, this becomes very common. In this case, it is a robot called Squid that is a warehouse robot that can do various things. Such as package retrieval and management and delivery of various kinds. So that's that robot. So you get the idea there. We also have now the drones, which are robots essentially. And in this case, people carrying drones are being experimented with actively around the world. And so eVTOL solutions are considered a real possibility now in various parts. So we may see something develop from that. There's another Hyundai's example with Uber. And of course, Mars is the only planet in the solar system, perhaps in the entire universe, which is entirely only inhabited by robots and no other. So far, we don't know. No other life form is natural or artificially intelligent. But that's robots on Mars that are making certain things possible. And we cannot go to Mars without robots. And farming is being revolutionized. So we have run robots mowing your lawns, or actually in the fields, in the farms, doing a variety of tasks, such as this robotic tractor, or in this case, a Saga robot that is growing strawberries and such. So there are lots of solutions happening. In this case, this is a forestation a robot. So this is a drone that can actually plant up to 20,000 seeds a day, and therefore it can make reforestation a fast and efficient activity that humans potentially cannot do or access, and so on. So there are a lot of things going on, including, and if you think worshipping has been left out, think again. So we got Bless You Too, which is an experimental robot that was developed in Germany, and it can bless in multiple languages. Go figure. That's already been done. And in China, there is a robot called Xian which is a companion robot for Master Xian Fan, and does a variety of tasks that a monk should. And so worshipping, and we develop certain relationship with the robots, and it is a real relationship. Anything that looks and feels like living, we develop a relationship with it. Even without that, we do, but I think with it, we empathize. Whether that is naturally intelligent, artificially intelligent, it does not matter. What matters is that something has agency that looks like it is living, that looks like it has agency, and we develop a relationship to it. Here is an example of a funeral held for dead robot dogs in Japan, and such things are actually fairly pervasive wherever there is a kind of a relationship and connection with robots. So we cannot think about robots as the other. That's my point, is that robots are not like a different species, somehow subservient to the humans, and that we can do whatever we want to. There are ethical issues involved. So robot ethics is an emerging field and a very important field at it. So the point is, robots are not them. And the reason is, when we think about a robot, we always think about it is out there. It is somewhere else. It's not me. And think again from these next ones. And so we have seen HAL 9000 and how it begins to, basically break Asimov's rules, because it may be jeopardizing the mission. So let me move to yet another example here. In this case, we're beginning to get into how humans interact with robots, and how robots begin to understand human emotions, human behavior, and such. And that interaction is utterly important. So they need to operate together. We need to work together. Without that, it is very difficult to make this work. Interesting things happen. So in this case, let's look at how this particular industrial robot behaves.
Humans and robots are companion species on this planet. We need each other. But it's also a scary thing. It replaces the need for some of what we do of our own labor. In my mind, we need to change these systems from replacing human labor to augmenting and expanding and incorporating humans into the process. The I just know is to find the win-win, that what I do with a robot is exponentially better than what a person can do alone, or what a robot can do alone. What we see now are a global community of researchers and designers and artists really challenging the basic premise of what these machines should be doing and can do. They can be basically reconfigured to put the human at the center of that experience and interaction.
We are in the Boston Dry Docks at Autodesk's brand new build space. So this is the robot I've been working with for the past 10 weeks. This is a ABB IRB 6700, and it's a machine that can move up to 7 meters per second. It can hold 300 kilograms, over 600 pounds. What we did here is we just gave this robot the ability to see us as we moved around in space around it. So we hooked up a bunch of cameras onto the ceiling, and we created some software that lets the robot see basically the entire environment around it. And what we're trying to show here is that we can actually, with really simple tweaks to this existing technology, we can make it responsive to people and make it easy to use by people. So just through your natural gesture, the way you might communicate with another person, you can tell the robot to come a little closer, or to come over here to come pick something up.
So a lot of what we're doing here is really pushing the boundaries of what natural gesture can communicate to this machine. The goal is to make this experience with the robot as intuitive as possible. And the fact that you're getting constant feedback between what you're doing and how the robot is responding, it lets you discover how to control and interact with it. Someone who's never even seen this robot before can begin interacting with it and controlling it. For people who have used and seen industrial robots, they probably have never seen it without it doing something or having something on the end of it, a tool for spot welding or gripper. So I'm hoping that it's a new experience for them too, to be able to see maybe more potentials for it, because they've never seen a robot that's moved quite like this, and never seen it so open-ended. There are really two sides of making this project and bringing this project to life. One half of it is the engineering and the logistics side of this, where you're on the computer 10, 12 hours a day, and then when everything comes together and you're in the space with the robot and you just have a very raw experience with this animal-like machine responding to your every move, all the technical aspects sort of melt away into the background. It's incredibly important to have opportunities and spaces to come in and experiment and misuse these existing technologies, because that's how you find innovations around our current problems. By doing this and by open sourcing these tools and by making it available, by sharing the knowledge behind this, and together as a community, we keep on lowering those barriers and making it more accessible and making it more exciting for people who don't see themselves as traditional roboticists or computer scientists, people that just want to nerd out about robots. You don't need to be an expert to do that. Everyone has permission to do that.
So there, I just wanted to play that whole clip because Madeline Gannon, researcher, she makes a very good point about why we always tend to think of robots in a utilitarian framework. And so there is something for us to think about. Can robots be just curious? Can they just be? Can they be without a purpose? And those are some profound questions we can and will ask as we move forward. And that raised the whole question of what is it to be a robot, and what is it to be a human? So here we have Sophia, political robot. Sophia has citizenship in multiple countries and can talk about a variety of range of political issues. And so the human form combined with AI, and in the context of a political atmosphere, an environment, in a context, the robot has been extremely fascinating. Now let's look at one more example. So in that case, what we have seen was, what we saw was the fusion of the machine and the human. So the biological and the mechanical, the biological and the cybernetic, the coming together. And there we don't quite know where the human ends and the machine begins and vice versa. So it's not the other. You see, that's the point, that we tend to think robots are the other, but they are infused or integrated, and we are going to see more of that. So in this case, wearable robots are another way that robotic agencies become part of the human agency, the biological agency. So in this case, colleague Benaz Fahi has experimented with wearable robots and robotic garments, if you will, that are responsive. So that I just wanted to provide us all of that context in order to understand when we talk about robots in architecture, we tend to only talk about a certain tiny segment or slice of what robots are and what robotics is, and as an extension also talk about AI and other concepts and other notions. So I wanted to talk about construction robotics, where we are and where we are headed. So within architecture, there are a variety of stages where robots could play a role and do play a role. The design stage, fabrication, on-site construction, or operation of the buildings and the environments. And first, let me talk a little bit about where we are. I think by the time I'm showing this to you, these are already 3, 4, 5 years old, but probably new to many in the industry, where the robots are beginning to do certain things. You can put end effectors at the end of the industrial robots, as Madeline Gannon did. She put the camera and the ability to respond. In this case, it is a bandsaw, and that can very carefully slice through a piece of wood along its grain, or in this case, foam cutting robot. With that, certain things are possible, like this. Our colleagues from across the river at MIT have done this foam tower. And in Europe, we've seen 3D printing metal in thin air. So with that, such things are becoming possible that would be very difficult or impossible to make in some cases without those technologies. Again, 3D printing metal, and in this case, bridge building robots that have been experimented with in the Netherlands. Are robots working in tandem, working to create denting sheet metal, in this case, to create structurally sound kinds of constructs that could do things like this, a bridge or a structure like this, all using just simply denting. And in this case, they have used some machine language in order to understand the material conditions that are not anisotropic. So you have to read what is the variability within the material conditions and how do you dent it, how far do you push it. So the material computation, some of what Mary Oxman talked about in the morning, talks about material computation or material-based computation, and this is one of those with metal. In this case, at Architectural Association London, they took an industrial robot into a forest, and they harvested certain forked tree branches, and with that, they essentially constructed this pavilion in the middle of the forest. So such things are possible. And you've probably seen this, some of you. If not, it's always fun to watch this, how drones have made a structure like this. And this is at Etaha, and they have built an interesting structure. So it's kind of reminiscent of honeybees building a hive, or anything, things like that. So different forms of robots doing different things. In this case, weaving, spider-like weaving, and this carbon fiber that is being woven, and pavilions constructed out of it, very lightweight and very different, very new, and new possibilities being revealed by these technologies. And so our construction site robots, where there are different experiments being done, in this case, a robotic mason. That could be a mason's assistant. A mason might deploy this companion robot assistant, if you will, on the site and be able to do certain things. Or specific tasks on construction site are being now, turned into, can that be a robotic a task that can be undertaken? So in this case, the iron bot does basically laying out, tying, and working with rebars and such. We've already seen this, either block laying or 3D printing at house scale, building scale, and or painting. So we have seen these specific tasks being accomplished.
Becomes reality.
Or Hilti robot that does
Introducing the Hilti J-Bot,
pretty
a semi-autonomous
strenuous tasks.
robot for ceiling installations, helping you to deliver MEP projects on time. Let's not wait for the future to come. Let's shape it together.
So, this one is Built Robotics, where this is again a concept, proof of concept video. So again, we see this notion of humans and robots working together, and this is Cobard's 3D printing robot.
Built with an autonomous printing machine capable of working day and night. This model is the most innovative and intricate 3D printed house to date.
So, and we have seen this morning, Rafat was showing some of these examples. Oliver, he was showing where it can scan and lay out, and or Nextera's Cube. It's a mini factory you can have on site, and or drywall installation robots. So there are a number of things. I cannot tell you how many startups are working around the world on these kinds of tasks. So at a certain point, there is going to be a tipping point reached. When it is, we don't know. Where it is, we don't know, but there will be one. And that leads us to another question of robotic architecture. Can buildings themselves be robots to live in? And yes, it is possible. And I'll give you some examples of that. So there are different ways of framing it. One is robotic components or robotic systems, like HVAC systems or various mechanical or electrical or other kinds of systems, or robotic structures. The structural systems themselves can be responsive, and or robotic space, where whole building could be a robot to live in. And so let's talk about that point on robotic architecture. In this case, this is a robotic library It's at North Carolina State University. So this is actually a real building. To scale, you see the red circle there that shows a human being. So this is gigantic robot. This is a multi-level, we're talking about 3, 4, 5-story robot that can retrieve and put back books, and now this has been replicated in many places. This is my colleague and friend Philip Beasley, who does artistic installations and sculptures that are robotic.
When people walk into the environment of this kind of sculpture, some reactions are quite anxious. What on earth am I looking at? What is this? Is it a science experiment? What is it for? Then the work starts to respond back. And so those kind of questions tend to turn pretty quickly into a kind of a curious, even wondering conversation.
So that brings us to a conclusion here, and let me now get out of this presentation and have a conversation with you. So, all right, so there we are. I wanted to give you a broad sense, a broad scope of what is happening, get a comprehension of all the fields that are being impacted by robotics, and how to think about them in the context of what we do. Why? Because as architects, designers, landscape architects, interior architects, and designers of any kind in general, we have to be aware of what is the kind of environment that we are being asked to shape, to respond to build for, and what are the possibilities. And as we have seen, every scale is impacted, every field is impacted. So the question for us is, how do we play a role in shaping this revolution? This is a revolution. Let's not mistake it. You know, my daughter the other day, she was doing a social studies assignment, and the assignment was about how robotics are impacting the society. And so children in schools are talking about it, learning about it, and so how do we as designers play a role in shaping this? How do we get to the table? And so that is where I'd like to leave this particular discussion and see what questions you have and talk about that. So I am looking at let's see, what role should architecture schools play in the evolution of robotics? Is a question from Anthony, and Anthony has another question: should robotics in AEC and architecture specifically be a specialty? Great questions, Anthony. And first, what role should we play? And that, I think the question is, what role do we want to play? That's really the question. And if we play a role, then we can shape it. If we do not play a role, then we'll be subjected to it. So the choice is ours. I personally think that we need to play a role. We should be at the table, and we should be certainly taking an active role. And that means that integration of discussions about robotics, understanding frameworks of robotics and artificial intelligence have to be part of the curricula and part of the kinds of programs we offer. It has to be part of the practices, right? So what Mary Axman talked about this morning about practice, and she and I were talking about how practices need to be transformed and rethought and reinvented to not just utilization and application of technologies, and perhaps development of technologies as well. So I think there is a big role to be played. As to what role that is, we'll need to figure it out, and we will figure it out. And the BAC, we are obviously thinking about it. And so that's a question I'd like to put there for our faculty and staff. So the next question is from Kyle, asking the Bauhaus found a theoretical approach to educate their students to reconsider the future. What approach should the BAC work to define to have our courses develop new thinking? Great question, Kyle, and that I think is a question in front of us as we think about redesigning our curricula and designing new programs, new academic or research programs. And that's an excellent question. So it's not just the question of a theoretical, but I think it is comprehensive role that we can and should play in shaping this. Why? Because if we do not, as Neri and I were talking this morning about the role of designers in the future, in the present and going into the future, and in fact shaping the future and realizing that future, we understand that we have a unique ability, a unique perspective, and unique set of skills that enable us to be able to see the opportunities to actually redefine the problems, not just accept problems as they have been defined by somebody else and given, but rather redefine the problems for the world at different scales, from little products to experiences to environments at every possible and conceivable scale. So it is also a question of equity. And that is something that we easily miss when we talk about technology, is that access to technology is a privilege. And it is a privilege that should be accessible to all, is my conviction and my belief. And that can only be done when we actually actively engage it. Certainly technology is wealth, technology is power, technology is transformational, it's revolutionary, it's nothing new. It's been going on for centuries now and millennia. I mean, technology, if you take the elemental part of it, it's always been a human enterprise. So it's integral, and I think it should be ongoing. And that is a good question that we are going to ask ourselves. So Sabina has asked a question: can you call a machine that obeys a program exclusively a robot? What if it acts but doesn't think and sense? And that's a great question, Sabina. And indeed, that is a question to ask about where do you draw the line? If the robots are able to sense, think, and act, I think the older breed of industrial robots were about non-thinking or non-sensing kinds of machines. But these days, all the robots that are being made are essentially, they have to be able to sense and think and act. Otherwise, they cannot function, and they cannot respond to the variability of the real-world conditions, real-world materials, and interactions. So perhaps, a decade or two ago, that we could have said that a machine is simply doing. So in that case, we can say a CNC mill, a CNC machine of any kind, is something that is executing a program, certain set of instructions. And it's that's why we call it computer numerically controlled. But the new ways of looking at it is that the industrial robots are replacing or displacing those older technologies and ways of doing it substantially, because they can sense, think, and act, and because they can learn. So learning is a huge part of this this feedback loop, and a huge part of the evolution of the knowledge. The technology as a form of knowledge is evolving because of that. So a question from Rodolfo is, do you think in the near future architecture and robotics will mix or work differently, and occupiable robots will work as architecture? I think any and all of those are possible, but to what extent will they be rooted culturally is a question for the designers. Otherwise, they can be curious experiments or idiosyncratic environments that we have seen throughout, and they are valuable, and let's not rule them out. But I do think that something will evolve from these kinds of intersections that we do not yet know. And that is why it is so exciting. That uncertainty, I think, is part of the excitement, but also part of the anxiety of it. And there is a question about, will the college need more labs, wet lab, robotic lab? Yes, yes, and yes, it is possible, but also the field. As we were talking this morning, that is not just a question of lab and controlled environments, but actually field conditions and on the construction sites and in the streets. Those are the kinds of conditions in which I think we will find ourselves actively intervening and designing. So that's what I think something prospects of what we can look forward to. And to go back to Sabina's questions about a machine that obeys a program exclusively, and there are things called teleoperated. So there is a spectrum of autonomy, right? So teleoperated to fully autonomous. So in teleoperated, they are at the mercy of an intelligence or agency that is external to them. So it could be a human being, it could be something else, as you control it in a variety of ways. But teleoperated is part of that spectrum, and certainly less intelligent part of the spectrum. But greater the autonomy, more intelligence is going to be needed, and more learning is going to be needed. So all of that. And I think I go back to Anthony's question that I don't think I fully answered, and that is, should robotics in AEC and architecture be considered a specialty? And remember, back in probably, shall we say, 70s and 80s, computation was a specialty. People thought that is something that people do in a corner. Even when I began my career, when I was getting into design computation, people thought that is a specialty. But now we all are engaged in it. We all are involved in it. And that is going to be the same arc of development with any new technology. So it currently might be a specialty. It is going to be a common curriculum at some point in the future. Just as we are learning about Revit and parametric design and such as a requirement almost in order for one to be able to be a designer and function and be employable and be actually effective in the field, the same is going to be true with robotics. Let's see, what other questions do we have? What role does architectural practice play when a computer can review a set of documents for having met all code and engineering requirements? And the same is true, actually, by the way, and this is a question from Kyle, same is true in law. In fact, there's a pretty well done experiment where a lawyer and an AI are given a set of documents. And when the task was completed, the human being made more errors and took longer time to review those documents for the legal code. Same thing happens with architectural code as well. If you train an AI, certainly an AI will learn. What AI is good at right now is a very specialized activity. So it's not general intelligence, is still some distance away, if it is possible at all. But I think we do have specific and focused and specialized areas where AIs do function and robotics do function. So where do practices go? I think that is where critical thinking as well as issues of equity and such need to come into play. Why do I raise that point? When we look at the kinds of jobs that the robots and AI will displace or replace or obviate, those often happen to be in the first wave. They happen to be, and I think Anthony also made the point in the previous session, and there was a good sort of discussion about the menial, the tough jobs. Those are the ones where they will enter and have a foray into the field, but they will soon do other kinds of things. as we have seen now with computers doing all kinds of things. Who would have thought a phone is now actually a computer? And so, yes, things are evolving and will evolve in those directions. Practices, I think, as Neri Axman rightly pointed out this morning, we really need to think about what practices do, what is within the scope of their work. Are they also going to be inventing technologies and taking intellectual property rights for them, patenting them, and so on and so forth is part of what they do? Yes, of course they can do that. You can choose to do it for strategic reasons, as Neri is doing. And so how practices innovate around this space and this line of thinking and this body of knowledge, I think is up to the practices. And it may well be that innovative practices will make headway and other practices may follow. It'll be interesting to see how innovation takes place within the practice setting. Another question from Anthony is, robots and automated construction will change construction. Today, architects write architectural graphic standards, have long done so, but that book will need to be rewritten in the future. Will architects write it if they don't know about robotics? Great question, Anthony, and I'm going to take that as a rhetorical question because I think we agree on what will end up happening with that particular task and line of work. So here we are at 6:59. So I'm going to see if there are any other unanswered questions, and we'll conclude this particular session. I think that's probably all the questions in the Q&A, and let's see if there is anything in the chat. Yeah, so let me just wrap it up and say I take a view that is neither positivist nor a Luddite view where it is completely opposed to technology. I think we need to take a critical view. We need to look at it from social justice perspective, perspective of equity, access, and power and empowerment. And we need to look at it from the creative opportunity perspective, that what is possible, and that these possibilities might actually allow us to be more resilient and sustainable. And so those are the kinds of possibilities I would like to look at, and certainly prevent and avoid the dystopian possibilities. So I love dystopian works, and I have written dystopian fiction and poetry and architectural projects. Those dystopian views play a role. They play a role by showing a future that we had better avoid. And so with that, I hope that we will all take this opportunity to actively engage with these new technologies and participate in this emerging revolution. And certainly at the BAC, we are committed to it, to investigate, to engage and explore, as evidenced by all that we have seen today. And to our alumni, say, extraordinary work that you've been doing. It's been very inspiring. And so it is my pleasure, privilege, and honor to have shared a few thoughts and a few frameworks about certain aspect of this technological spectrum. So with that, would like to thank you all and wish you a continued great sessions. The next couple more sessions, let's look forward to that. Thank you.